There have been several students that have asked me for assistance on task 3, which is trying to integrate 3 first-order differential equations. So I'm going to do this video. Hopefully this can make sense to you. On the Google Drive, MECH 3352 directory MATLAB programs, there is also a directory called ODE Solver, and in that directory is an odesolver.m. I'm going to open that file. I would recommend that you start with this. The integration, the one that does the actual work of solving the differential equations, is right here in blue. You can get some help on the MATLAB and read the documentation. Essentially, there are 3 necessary arguments that you send to this function. The first argument is kind of a weird looking one. You don't really need to change this any, but let me explain what this is. This is the name of a function that you will write that will calculate the derivatives of all of the equations. So in your case, you have 3 variables, x, y, and z, and so you will need x dot, y dot, and z dot. If you have a higher order equation, remember I showed you how to take the high order, like, to the third derivative equation, and break those down into 3 first order equations. So you can always, no matter what you're solving, you can always convert the high order equations into first orders. And that's what Ode45 will do. It will solve first order equations. You will need a function that tells Ode45 what the derivatives are. That's what I have highlighted in blue. The name of the function is get the dot. You can name it anything you want. If you name your function something else, you need to change this word get the dot to the name of the function that you have written. All right. When I wrote my function called get the dot, there were 3 things that were going to be sent to it. First of all is going to be the time. Here I'm calling it TT. Remember, in MATLAB, the arguments depend on where they are, not necessarily their names. So TT is the first argument. That's going to be the time. It will send my get the dot, the current time. It will also send it the variables, and it also sends it this is optional, the stuff that you need to calculate the dot. So for example, when we were doing Euler, we were doing a cosine or a sine term, and we had a frequency in that sine term, and that's what I needed to have for the other one. So that stuff for the dot, that was me naming that. That was an optional parameter of anything that you might need in order to be able to compute the derivative. That's what goes there. So that is in the @ sign in front. That's weird, but it's a requirement for MATLAB. Basically, the @ sign says this guy that's in blue is the name of a function. It's not a variable or something like that. It's the name of a function. So that's how it knows that get the dot is a function name, not a variable. Okay, so that's the first thing that you pass to it. The dot dot dots, by the way, are just a continuation line, so that way it makes it easier to read. The second variable is the time range. This is going to be a vector. If you read the documentation, there's 2 things it can be. One is a beginning and ending time, and the other one could be all of the times that you want the value. Okay, I am using initial and final time. So if you notice it in blue, the time range, look up here. It's faint blue. That's where it's being defined. The time range is a vector, right? Because it's got the square brackets. It consists of initial time, which happens to be 0 in this example, and end time, which happens to be 5. You could put a 0 right here. Nothing wrong with that. But it's not considered good programming practice because you don't really want to take things that might change and embed them in the code, because what will happen is your boss will come back later and he'll say, oh, I want the ending time to be 15 seconds, not 5. And if you have 5 embedded down here in the code somewhere, it will be, I'm telling you from experience, it'll be difficult to find them and get rid of them. So the best thing to do is to, instead of using the number, use a variable name. So initial time, I'm going to just copy and paste it back in there. But it'll run even if you just put the numbers in there. Just be careful though. Changing it is going to be more difficult. Okay, so that's the time range. I've specified it. I want ODE45 to give me solutions between time of 0 and time of 5 seconds. That's what that guy does. This thing here is the initial value. Now, this ODE45 was set up to solve one equation, and that's why there's one initial value. Initial x is a 2. It's not a vector. It's the number 2. That's the initial value of x. And if you remember from the Euler routine, hopefully you remember, in order for that guy to work, it has to know what the value of your variable is now. It has to know what the time is now, and then it approximates the value of your variable in the future. Okay, so it needs to know these values now. All right, one equation, one value of initial x. This is the stuff that I needed to calculate the derivative. So in this case, it was a cosine term, and I needed to know what that frequency was in the cosine term. And so that was extra things that I needed to send to it. You may not need that in task 3. If you don't need it, it's okay to leave it there. It doesn't harm anything. Just make a note to yourself that that's what it is. It's just extra stuff that may be needed. And then, of course, here's the plot and everything else. Okay, here's what I'm going to do. I want to modify this to integrate, let's say, 4 equations. Okay, and they're going to be different equations than what is in task 3. After all, you got to do something, right? So let me just write down what the equations I want to solve are. Okay, so here's a comment. So let's say that x dot is equal to x, and we'll say the second equation is y dot plus x dot is equal to y. Okay, I'm just making something up. I have no idea what this is. And then, well, let's just do 2. 2 variables. And for task 3, you're going to do 3, x, y, and z. Okay. First thing that I'm going to do is if you have 2 first-order equations, you need 2 initial conditions. If you have 10 first-order equations, you need 10 initial conditions. If you have a higher order one that you converted down, you still need the same number of initial conditions. So I need 2 initial conditions. So the initial x, I'm going to call it, let's just say x is my variables, okay? I need 2 of these, not one number, okay? So in MATLAB, the easiest thing to do is just put it in brackets and say, I'm going to give you 2 numbers, right? So what this means is the first variable, the initial condition is 2. The second variable, the initial condition is 3. Now, how does MATLAB know whether x is the first or is y the first? How does it know? It doesn't know, and it's up to you. So, for example, what I'm going to do is I am going to do something crazy. I'm going to say that the y is the first variable in the list, and x is the second. Okay, just to make a point, I'm going to make it calculate y first, and then I'm going to have it do the second variable. It's going to be the x. You can put them in any order you want, but once you decide what you want, you got to keep it that way. So if y is the first variable, this 2, that would be the initial condition of the first variable. That's the initial condition of y. The second variable is the initial condition of x. So that's what, now if you wanted x first and y second, you would put 3 space 2, because 3 would be the initial condition of the first, 2 is the initial condition of the second. So that's how you're going to decide which one is which. Now you've got to keep it straight, because that, once you make that decision, everything through here has to be the same. Okay, now the initial x, you see that? It's right there. Okay, when ODE45 accepts this variable, it's going to know how many numbers are there. It's going to say, oh, you got 2 numbers in there. Okay, there's going to be 2 equations, 2 differential equations that are first order. That's how it knows that it's solving two equations and not one. Okay, it's right there. All right, so what else do I need to change? Well, is the time range okay for you? Sure, no problem. Doesn't matter how many equations, they're going to solve all of them for the same period of time, right? So that, we don't need to change that. That never, well, the only time it would change is if you change the end time or the initial time or something, okay? So far, everything's good. Now, it's going to take these numbers, it's going to call ODE45. What ODE45 needs to know is, it knows the value of the variable, it knows the value of time now, right, the initial time. It needs to know what is the derivative now. So now what we need to do is we need to focus on get the dot function, or whatever you decided to call it. So we'll scroll down here, and here's the get the dot, right? It's a function get the dot, and it returns the dot is. That's what I'm going to call it, and then the ODE45 accepts that variable. It doesn't, ODE45 has no idea what I call it. It doesn't matter. All it knows is that the first variable that comes back is the derivatives. That's all it knows, and you can call it anything you want. Okay. So what I'm going to do is I'm going to type in my equations. So I'm going to copy them down here so I don't forget what they are. And remember, y is the first, x is the second. So here we go. I'm just going to copy them down here just so I get it squared away and straight. Okay, there we go. All right, now I'm just going to type in x dot. Okay, x dot is equal to x, right? Y dot is equal to, let's see, that would be y minus, now if you're saying, wait a minute, I don't know what x is. Yeah, bear with me for just a minute. Y dot is going to equal y minus x dot. Okay? Now, this is okay because in line 50, after it knows what x dot is, it's okay to use it down here in 51. Because it knows what x dot is, it can substitute that in. If you, for example, did this, get away from there. Okay, there we go. If you were to copy this like this would be a mistake. If you put in this one first, line 50 doesn't know what x dot is yet. And notice it's red underline. It doesn't know what x dot is yet, and so it can't, calculate line 50, right? That's why you have to put them in that order, right? Or somehow, but you got to make sure that you can get what you need here. Okay, so this one's going to be all right. You see that? Okay. Why is y dot underlined in red? Because I haven't used it for anything yet, and it's just letting me know, why did you calculate it if you're not going to use it for anything? Well, relax, calm down. I'm going to do it. Okay. Now, what is x and what is y? Well, that is the get the dot. If you notice from up here in ODE45, it's this guy right here. The first variable is the time. The second variable is the value. Now, how do you know that? Look up the documentation on OD45, and it'll tell you the first variable is the time. The second variable there is the value of the variables. Okay, so that's how you know which one goes first. The documentation tells you that. So the second variable is the values. What do you want to call them? The null, that tilde means it's there to hold the spot, but I'm not using it because in the previous example you didn't need it. Okay, let's call it xy. Okay, or rather, what we ought to call it is yx, right? Because y is first, x is second, and you can call it George if you want to. It doesn't make any difference. I'm going to call it yx as a reminder that this variable, the first guy in there is the y, the second one in there is the x. Okay, so yx. All right, so now I need to know what x is in order to do line 51, right? What in the heck is x? Okay, well, x is going to equal, it's going to come in through the variable called yx. Is it the first guy in the list, or is it the second guy in the list? Well, look at 48. Line 48 says y is the first number, x is the second number. So what I want is the second number of that list. what is the value of y? Well, the value of y is going to be yx, and he's the first number that's in there. Okay, so now you know from when you execute line 50, it's going to know what x is. And that way it can use it in line 52. And then when it does 51, it knows what y is, and it can use it in line 53. Okay, so those are my dots. Now, I have to return the value to ODE45 so it knows what my two derivatives are. Okay, so here's what I do. The dot is the output variable. See it in line 49? The dot is equal, and then you have the function call. So the dot is the values that are sent back to whoever wants it, which is ODE45. So what I have to do is I have to say the dot is, and it's equal to what? It's equal to two numbers, right? So that's why you have to put a bracket in here. There's going to be two derivatives. Which one should be first? Y. Why y? Because I decided I wanted y and then x. That's why. So I'm going to say, all right, it's the y dot. Okay, that'll be the first derivative that I send back to it. The other one is the x dot. Now, if you put more than 2 in here, it's going to freak out and give you a mistake, because it's going to say, now wait a minute, you gave me 2 initial conditions, but now you're giving me 3 dots. That doesn't make sense. Or if you give it 3 initial conditions and only give it 2 dots, it doesn't match up. It won't make sense. So that's why it has to be 2. Okay. Now, and that's why the y goes first and the x goes second. Now, I've made a mistake, but I don't know it yet. Don't worry about it. I'm going to show you what happens. Okay. So now these other 2 lines I can get rid of. That was from the original one, right? So I'm just going to get rid of those guys. Okay, so now what I've got is I changed the initial values, right? So that it tells it what the 2 initial values are. And then I've also changed the get the dot function so that it will calculate 2 derivatives, not just 1. Now for task 3, you have 3 variables. You're going to have 3 of these and not just 2, right? Your equations are different as well, so you'll have to change the statements that calculate the derivatives of each of them. Okay, so I think I'm done. Let's try to run it and see what happens. Okay, I have an error. What does the error say? It says line 93. So here we go. Where is, oh, excuse me. In ODE, no, in ODE solver, no, where am I? Okay, ODE solver line 13. Well, I'm not sure what these lines are. They're probably in ODE45. Anyway, here's what it says. It says that this get the dot right there, get the dot, must return a column vector. Okay? If you remember from MATLAB, there are, you can put your numbers in rows, and you can put your numbers in columns, or you can put them in like a matrix, rows and columns, right? What it wants is it wants it to be in a column. It wants y dot and then the x dot, in 2 rows, 1 column. That's what it wants. So the syntax on this is wrong. When you put a space in here, what it does is it goes out the row from left to right. If you want it to drop a line, you put a semicolon. Now it'll put y dot, and then on the row below it, it'll put x dot. So now this, the dot will be 2 rows, 1 column. Okay, so it's a subtle difference, but fortunately, if you read the errors, you can get a pretty good idea as to what's happening. Okay, so now let's try it. So we hit run, no error, and the equation pops up over here as a plot. Okay, so that's how you do multiple equations with ODE45. Okay, that's it.